Hey everyone, this is Michael from the Data Incubator. Really excited to have you here and really excited to be joined by Becky from Netflix. So this is still a little early. We're going to give folks some time to wander in, come in from their coffee breaks and so on. So we'll just hang tight for now, but we'll be starting shortly. So excited you're here to join us. Hey everyone, for those of you who've just joined us, thank you so much. We're very excited to have you for our 7th Data Science in 30 Minutes. As you probably know, this is a webinar series where we bring in folks from really all over industry to come and speak. Previously, we had Jess, who was the Chief Data Officer at Quantopian, speak and talk about her experience doing portfolio optimization using data science. I'm coming to us from Boston, and now we have Becky from Netflix, who's joining us from, I think, LA, right?
That's right. I'm in our new LA office.
Very nice. So from the other side of the country, Becky will be talking about content prediction, and I'll let her speak about that shortly. I think right now, I guess I'll just say a few words about the Data Incubator and what we do, and maybe about the Data Science in 30 Minutes series. And this is kind of just, we'll be starting in a few minutes, but I want to make sure that we give people time to show up and join us, especially if they're running a few minutes late. So the Data Incubator, so yeah, as I said, I'm Michael Lee, founder of the Data Incubator. We're a free fellowship for PhDs and master's students. And you can go apply online at www.thedataincubator.com. We also do a lot of corporate training. So we help people at existing companies, whether that be like AIG or Capital One or Cisco, who are looking to sort of upskill the workforce that they currently have. And yeah, I think that's actually most of what we do. We're very excited, obviously, about data science education. And we really love sort of hosting these events to get people more acquainted and caught up with data science. So without further ado, let me introduce Becky. So Dr. Becky Tucker is a senior data scientist at Netflix, a streaming media entertainment company based in Los Gatos, California. She works on the content science and algorithms team, which is located in Los Angeles. She holds a PhD in physics from Caltech. And at Netflix, Becky works on models that predict the demand for TV shows and movies. So without further ado, do you want to take it away?
All right, thank you very much, Michael. As Michael said, I am a data scientist at Netflix. And let me go ahead and share my screen. Maybe. This worked just a moment ago.
Oh, I think it's coming on. We can see your screen now.
All right. How does that, is that all right? Am I in presentation mode now?
You're in presentation mode.
Excellent. Glad to hear it. Okay. And if I switch back and forth, is that bothering you guys, or do you still see the same thing?
See the same thing.
Perfect. Okay. So what I wanted to talk about today is a little bit about how we are using data science at Netflix to predict demand for content. And I call this beyond recommendations because I know that when you say Netflix and data science, the first people think about is, of course, the Netflix recommendations algorithms. But of course, Netflix is an extremely data-driven company, and we apply data science to every aspect of the user experience, including content. And I think that's one of the more interesting and more nuanced ways that we're using data science. But I did just want to start briefly with some background about Netflix. I'm sure the vast majority of you are completely familiar with it, but just to provide context. So Netflix started as a DVD service in 1999. Many of you will remember those ubiquitous red envelopes. At one point, they were mailing more than 2 million discs per day. We became a streaming service in 2007. Some of you may remember that our big title at that time was Heroes. I know I myself actually joined to watch Heroes at the time. 2012 was another major moment for us. That's when we started creating our own original content. So this is content produced by Netflix for Netflix. House of Cards, I think, flashiest original content, although many people mistakenly think that it was the first piece of original content. That was actually Lilyhammer. It just wasn't quite as memorable and as successful as House of Cards. And then our most recent big change was that we expanded to global in early 2016. And so you can now view Netflix basically anywhere in the world except for, I think, China, North Korea, and Syria. And this also includes a change in some of our original programming strategies where we are also now producing Netflix originals for non-American markets. So that would be things like Club de Cuervos in Mexico, Marseille in France, or Terrace House in Japan, if any of you want to check those out. A little bit about Netflix today. We have 93 million members available worldwide. And then just to speak to a little bit of the amount of data that we could be dealing with for any particular algorithm or analysis, we do support a lot of devices. Netflix is available on laptops, smartphones, gaming consoles, smart TVs, pretty much anything that streams has Netflix. There are more than 3 billion hours watched per month, which to us translate to more than 100 billion events logged every day. At the highest point, I think we were 36% of peak US downstream traffic, according to Sandvine. And that's actually declined over the past year due to us getting better at encoding our content. And all of this is just to bring home the fact that we are living in a really big data world. So our data lives on AWS. We access it with tools that many of you will be familiar with, since they're things that are built on top of MapReduce, like Hive, Spark, things like that. So that's where we are now. But here is where we started in the early 2000s. So just as Netflix has evolved over the years, data science at Netflix has also evolved over the years. It wasn't called data science back then because data science as a term of art didn't exist, but we'll continue calling it that since that's what most people understand. And in fact, our earliest data science efforts were focused on recommendations. Back then, there was no streaming or play data to directly use as a signal to recommend and suggest titles to a user. So we used information like the star ratings to make recommendations to people. Additionally, talking about content demand, back then there was essentially no data science to be done for content demand. During the DVD days, essentially what we would do is put everything that we knew about in the world up on the website, and if enough people added it to their queue, we would go out and buy the DVD. We didn't actually have to have the DVD in order to let people add it to their queue. And when it reached a certain threshold, we would just go out and buy it. And there was a simple formula that essentially took into account the number of times a title was added to a queue and how often DVDs break in the mail, and that was it in terms of predicting content demand. So everything changed when Netflix started streaming. We started making recommendations based completely on streaming data. This culminated in the Netflix Prize, where we challenged people to take our existing personalization algorithm and to beat it by more than 10%. And the winning team would get $1 million. This was it was a cool era to be working on this. It spawned a ton of really good ideas, a lot of interest in machine learning. In a lot of ways, it was sort of the prototype for Kaggle and Kaggle competitions. But ultimately, the Netflix Prize was never implemented at Netflix. And this is, I think, one of the things that that is brought home when you start doing data science in the real world, which is that there is a trade-off between accuracy and functionality. So the final winners of the Netflix Prize had an ensemble model that had more than 100 individual models that went into it. It couldn't be productionalized. And one of the things that you have to consider is data science in the real world is not just about accuracy. It's also about latency and ease of maintenance and ease of production. And so you might find that you have an algorithm that is, in fact, worse, maybe 1% worse, but if it's 10 times faster, that's a trade-off that you might be willing to make. All of this, it's not to say that that we haven't made a lot of progress since then. The algorithms and machine learning behind recommendation and personalization today are in fact incredibly sophisticated and nuanced. Personalization today is not just a single algorithm. There are algorithms that determine not only what content gets displayed to you in which rows, but which order those rows appear on your page. The data science teams here touch essentially every part of the Netflix experience. So what you see in this large billboard experience, or what images you see. We A/B test what images are placed for each piece of content. That data science also touches streaming and quality of experience. So if we know that you're streaming on a poor internet connection, we'll change the encoding algorithm so that you get fewer rebuffers. Messaging, so messaging and discovery, so how we email you when a new title becomes available. All of that is touched by data science at Netflix. And it's all geared towards trying to make great recommendations of great content. And one of the fundamental truths here is that in order to recommend great content, you have to have great content in the first place. We can only recommend the titles that we actually have available on the service, unlike in our DVD days. And there are so the question here becomes, what titles can we either buy or create to optimize our users' joy? And that really is the metric we think about at Netflix, is what brings people joy. And we think that, of course, highly correlates with things like growth and retention and those business-oriented metrics. But the question becomes, what do we produce or buy? And the two pieces to that puzzle are our original content and our licensed content. Regardless of whether something comes to us as an original or as something that has already been created, it has to go through a selection process. And that's a little bit what I wanted to talk to you about today in terms of what we do on the content team, content science and algorithms team at Netflix. So value attribution on a subscription service. There is a real difference between the way, for example, iTunes might value a piece of content versus us. iTunes, it's transactional. You pay $6.99 for a movie, and that's the value that both you and iTunes are getting from it. If you think about content, what makes content valuable traditionally, you have things like the box office amount from a film, or for TV, you have Nielsen ratings, which might help you figure out a target audience size, and then based on that target audience size and demographics, figure out what a company like Budweiser might pay to reach, for example, the 25 to 35-year-old men who watch Big Bang Theory. They don't have as much data as we do, so even with this data, they don't know exactly who is watching their content. And additionally, it's suboptimal because even with the data they do have, they don't necessarily know how that converts to product purchase. So Budweiser may know what they spent and how much time their ad got, and they may see sales rise, but they don't actually know the direct correlation between people who saw this ad and then went and bought something from their brand. Netflix, on the other hand, has a lot of ways to consider what makes content valuable. So the simplest version of this is you might say just, well, how many hours was it viewed? This becomes tricky really quickly in terms of defining a metric, because defining a metric the wrong way can lead you to really bizarre incentives. So with something like how many hours is something viewed, there are ways that you could start changing the kinds of content you make available to optimize for that metric that really are not good for the service in the long run. So for example, you may find people view more hours of longer content. So instead of making 2-hour movies, we should make 6-hour movies or 8-hour movies. Or for example, we could try the most viewed things on YouTube, which I think the most viewed video on YouTube is Gangnam Style, which is great for YouTube, but maybe not great for Netflix. You could also ask things like how many people finished watching it. So if they start something and it gets viewed a lot, but none of them finish it, is it really a valuable piece of content? You could ask, did people sign up for Netflix to watch it? Did it generate new subscribers? Did it win awards? How do you value the contribution of winning an Emmy or an Academy Award? Is it popular with critics? Is it binge-worthy? Is it a cult favorite like Arrested Development or the reboot of Wet Hot American Summer? So given that we have so much more data, we can also construct more elaborate metrics. We can actually look at all of these things when we try and think about what makes content valuable. One thing that you might hear sometimes in terms of Netflix's notion of value is this idea of content efficiency, which is simply stated the value of a piece of content to Netflix divided by its cost. So if it's over 1, then we're getting more value than what it cost us. And if it's less than 1, we're getting less value than what it cost us. Luckily for us, our original content is in fact some of our most efficient content. That ends up being a good thing for us because it means people come to the service for content from Netflix, and if it's only available, you're probably more likely to stick with the service. Given this context, I'd like to talk a little bit more about how we actually predict demand and predict value for a piece of content from Netflix. I'm going to start with the case when something is licensed. So this is non-original content. It's been made by a studio separately from us, and we are just acquiring the streaming rights. That we do actually is we acquire a database of essentially all available titles that we'd like to make a prediction about. We have a database of all available titles and all kinds of any kind of information that we actually can find about that title. And this actually becomes a massive data acquisition and engineering problem. You've probably heard the truth at this point that 80% of data science is actually data engineering and data cleaning, and that's certainly true for what we do. Our data engineering teams are really the backbone of data science at Netflix. It is a massive data engineering and sometimes even data science challenge just to do the entity resolution. So for example, with a movie named Frozen, if you don't successfully dedupe, not even dedupe, successfully differentiate between things that are talking about a small budget horror film set in the mountains versus a massively popular Disney movie about 2 princesses, you can imagine that the garbage out, the predictions we might make about a title named Frozen would be incredibly garbled and unclear if we don't get this right in the first place. You can't do this by simple string matching. Another one of my favorite examples here is this Pocahontas example. So you might think, okay, well, so all you need is maybe a title and a release year. Unfortunately, in 1995, there were 4 titles released named Pocahontas, all of which were geared at kids, all of which, or 3 of which were animated titles. If you're interested in this kind of problem, I recommend a Google search for record linkage methods. There is actually an entire body of literature on how you take different data sources that may or may not be talking about the same entities and merge them together in the best possible way. So that being said, this is a moment in which I would like to plug the fact that the data engineers and data engineering teams at Netflix are really spectacular, and they do a really great job of making the data scientist's job easier. So once we have conquered that part of the data acquisition and cleaning challenge, we start putting together our demand features, and essentially we try and find anything that we think might have some signal. So that it would include past performance on Netflix if it was a previously licensed title. If we've never licensed it, we might consider the past performance of similar titles on Netflix. So if we're looking to license a horror film, we would look at how other horror films have done. We could include things like broadcast ratings, the box office, the talent involved, reviews, awards. If we can get our hands on it, we will try to include it in our models. Our predictive models, I'm sorry to say that I can't actually get too much into the details of what specifically we do. But what I can tell you is that if you have read about it, we have probably tried it or are currently using it in some area in Netflix. So we are using everything from your basic regression models, gradient boosted decision trees, a lot of matrix factorization methods, clustering, LDA, and NLP techniques, neural networks. Someone somewhere at Netflix is using that to help make the Netflix user experience better. So once we get a prediction for a piece of content, it actually doesn't stop there. I think this is another one of the truisms about data science in the real world, which is that domain expertise matters hugely. It is not enough to just take your data and run it through a machine learning algorithm. There is a lot that isn't captured in your data. There's a lot that can't be captured in a model. And in addition to that, we're still working within a really old Hollywood system. So sometimes you may get a prediction, and based on the cost, you might say, well, that's inefficient, we shouldn't buy it. But if it's part of a larger deal, because we're trying, if we buy film A, we might be able to get film B, or we're doing it to build a relationship with a studio or with an actor or a director or something like that. We may proceed for other reasons. Buying deals and streaming rights deals are, as I've come to appreciate, incredibly complicated and nuanced. And so the numbers actually are the beginning. So the predictions are actually the beginning of the conversation, not the end of it. One of the things that we have had to address at Netflix as part of content demand is that we don't have a single content demand model. We actually have many, many content demand models, similar to the fact that we have many, many recommendation models and many personalization models. And so, in order to deal with that, we actually ended up building a custom machine learning framework in order to address both the multiplicity of models and the fact that we're dealing with big data things that won't just fit on a laptop. And so we actually have a YAML-based machine learning framework. And YAML stands for yet another machine markup language. And essentially what it allows us to do is to write config files that specify and separate feature engineering for training, the algorithm and model that we're using for training, feature engineering for scoring, and our scoring, which in this context we mean getting a final prediction in a production environment, to make those all separable and repeatable. One of the really cool things about this framework is also that it's inheritable. Which means that if you have a base model, you can have submodels that inherit from that. And so if you want to say, add a feature that turns out to help a lot in the prediction problem, you can just add it to the base model, and that feature will flow through to all of the subsequent models without you having to go through and change each one. I know we're hoping to open source this at some point, but it is not there yet. Before I run out of time, I also wanted to briefly address our value prediction problem for originals, which is a much more difficult problem than the licensing value prediction problem. We have much less data, so if something hasn't been created yet, we have no box office or review data to use. It's a moving target, so ideas and scripts can change wildly between when they're pitched and when they're actually made. And the execution can vary widely with talent and budget. A director, same script with two different directors could turn out to be very different. Just briefly, an example of how messy this can get. We have the example here of the Revenant. The book was optioned even before publication in 2001, where Samuel Jackson was attached to the lead role. In 2007, it appeared on the Blacklist, which is this annual list in Hollywood of the 100 best unproduced scripts. At that point, Christian Bale was attached to the lead role. It wasn't until 4 years later that it finally was funded at $60 million, and Leonardo DiCaprio got attached to be the star. It was finally filmed in 2014 at twice its original budget. And then in 2016, it won tons of Academy Awards and made $530 million at the box office. So this is a really messy process, and trying to figure out how to use data science to optimize anything in a process like that gets really tricky. One thing that we do is that we, instead of trying to attack it from that sort of first principles approach, we try to find comparable titles and use what we know about those titles in order to predict how we think an original title might do. So maybe when we were originally looking at the House of Cards script, we say, well, this is kind of like The West Wing meets Breaking Bad. Well, those are titles we've actually had available on the site, and we know that the people who watch those titles also watch Mad Men and The Blacklist and Homeland. And so then we might make predictions on the basis of how well these comparable titles perform, with adjustments from domain experts who might know more about this process. So we are trying to inject more science into this process via techniques like matrix factorization of play data and natural language processing and stuff like that. But this is as much of an art as a science. So for example, if you ask an algorithm without having some additional nuance or understanding of what's going on here, what's a title comparable to Twister and Jaws? You might end up with something like Sharknado, which, while I'm sure is a high quality movie, you might not consider to be quite the same level of production as movies like Twister and Jaws. And lest you think I'm totally joking here, this is an actual example from an experiment we ran here. Another thing that comes up a lot when we talk about data science and content at Netflix is this question of, can data science create content? Do we have an algorithm that just spits out scripts or tells us yes or no on whether or not a script is good? And so, for example, there was a screenwriter, sorry, an AI screenwriter that wrote a script that got made into a film. And it was, you should go watch it. It's available online. And it's entertaining. You wouldn't exactly call it great content. And so the answer to, is Netflix doing this? No. As I mentioned before, the way that we handle content prediction is that that's where the conversation starts. That's not where the conversation ends. And we really do pride ourselves on giving a lot of creative freedom to creative people and getting out of their way to let them do their job. But data can definitely help in choosing content. When we think about both what we're doing and what's next in terms of using data science to create content, we're thinking about how can we use data science to optimize the catalog. In the extreme example of having a catalog that is, for example, only comedies, right? That's not ideal. Additionally, we are also thinking about how do you identify valuable content earlier in the pipeline. And this is really about giving our creatives better tools and letting them better do their job. So I see now I've got a bunch of questions, so I will wrap it up here and see if I can start taking questions.
Yeah, absolutely. No, thank you so much for that. I just wanted to quickly interject and say, I'm glad you sort of gave a call out there for Narcos, Marseille, and of course House of Cards, which are some of my favorite Netflix shows. I'd love to just ask you a question. When you were talking about how do you measure predicting licensed content and sort of the machine learning models you did there, can you share with us how you measure success? Is that sort of number of people watch the show, or what is the Y variable?
The Y variable, it actually varies a lot. So we actually internally have many different metrics related to content demand. So that includes both like some of the really obvious choices, like number of hours that a piece of content is watched, as well as looking at essentially we look at a share metric. So what share of viewing did this particular piece of content get? Because a metric like raw view hours, as you can imagine, can get really tricky when your service is growing its number of subscribers every year. So content hours will go up regardless. And so you have to disambiguate those cases.
Got it. Very cool. And then you also said you wanted to measure user joy. How do you measure? Is there sort of like an ultimate user joy metric?
If only. No, that is. I think that is really so. So that is how we like to think about what we're doing here. And there are a lot of ways to measure user joy, and we've thought about all of them, I think, and they're all imperfect because it is really a nebulous concept. But the point of framing it that way is really to remind ourselves that sort of really intense focus on any one specific metric for too long will eventually lead you astray. You'll end up with really bizarre outcomes if you get too focused on one slice of the business.
Yeah, God, no, I think that's very well said. So I will just read off some of the questions that the attendees had. And thank you for all those of you who attended. I know we had over 2,000 folks sign up. So very thankful that you were able to make it, and I hope you have enjoyed it so far. So from MyS227, how many experiments do you, I guess you guys at Netflix run concurrently? Is there always an experiment running?
If you think about Netflix as a whole and not just content data science, yes, there is always an experiment running. And many dozens or hundreds of experiments are typically being run concurrently.
So from Josh, If the $1 million model, that is the winning Netflix model, was never implemented, what were some of the key learnings from that competition that made it into production?
You know, this was really before my time. I think that what we so I think that what we learned from this is actually that that what you what you rated as a star rating and what your behavior actually is on the service are actually not the same thing. And I'm sure you all experience this as well. I have what I call my aspirational queue. So I have tons of stuff in my queue that I've basically put in there because I'd like to think of myself as like, oh, I'm the kind of person who watches high-end classic movies. And so I have all this stuff in my queue of, Casablanca, we have Casablanca at the moment, but it's like all of these, sort of classic movies that I feel like I should be watching. Whereas if you look at what I'm actually watching, it's, Sherlock and,
I was going to say, what's your guilty pleasure here?
Yeah, the Great British Baking Show, right? And so what I say I'm going to watch and what I actually watch turn out to be different things. And so once you have that insight, it changes the way you think about recommendations.
And so does that mean are you then trying to generate content, or sort of acquire or create content for the aspirational queue or for the guilty pleasures?
We are trying to, that's actually, it's an interesting question because it gets back to our question of value and when is something valuable. And I think it's an open question. If, is a piece of content valuable if lots of people like seeing it on the service but don't watch it? And that's a tough question for us to answer.
That's fair enough. So from at Gualva, I'm going to butcher this, Gualva Reina, Netflix has different titles for different countries. Is that just because of copyright issues, or do you calculate a score for each country based on each country's data?
This is a patchwork of things. So particularly for licensed content, it often is not available to us in every country to buy streaming rights. So oftentimes, like a local broadcaster will have already bought the rights in that particular region or country, and they're just simply not available for us to purchase. So we might purchase it everywhere, but in 2 or 3 regions because we simply can't do it. There are some titles that we will only acquire in certain regions if the economics of it don't work out to acquire it everywhere. So it's a little bit of both.
And I guess sort of the determination of which region to acquire it for is definitely driven by the work that you and your group are doing.
Yep.
So from at Scodium, I think the question is, when you're thinking, how do you think about, for new content, how do you think about the factors that you're using in your models? How do you know that you've sort of come up with good factors, sort of meaning features, and sort of identifying users that might map more heavily onto sets of features? How do you think about that?
In some ways, it's not that different because at the end of the day, we are setting this up as a machine learning problem, right? So we have a data set, we have a model, we have an error metric at the end, and we do a lot of experimentation with features. So if we add a feature and it helps or and it hurts, then you know how to make that decision accordingly. The difference between our license and originals prediction problems is really about data availability. And so, I think that you'll find in a lot of data science contexts, the fanciest algorithm in the world doesn't help you if you're it wouldn't help you as much as expanding your data set tenfold. So we certainly see that truism here as well.
Yeah, absolutely. I know that I forget who it was. I'm picturing him right now, but I can't remember his name. Had this great expression of the the unreasonable effectiveness of data.
Exactly, the unreasonable effectiveness of data. We find that to be as true as anybody.
Yeah, and then any word on when the custom sort of ML machine learning framework, I think you called it Curie on the slides?
Yeah, it won't be called that if we do end up open sourcing it. No, I know that we at Netflix, we really do believe in open source and open sourcing as much of our internal systems as we can. The Netflix blog, if people are interested, there's a Netflix tech blog that talks a lot about stuff that we've open sourced in the past. There's no immediate timeline for us on the ML framework, though.
All right, wonderful. Yeah, well, thank you so much for being here with us. And as I guess as I sign off, the only thing I would say is, for those of you who are interested in learning more about data science, would encourage you to sort of check out the Netflix blog. You can check out our blog at blog.thedataincubator.com, and you can apply for our free fellowship for PhDs and master students, and also our foundations course, which is sort of geared towards giving people professional hands-on experience in the foundational techniques of data science. And we'll put up links to that on the YouTube channel right after this. All right, thanks so much, Becky.
Thank you very much. Have a good day.
Cheers.
Bye.